So yesterday we did arc length and circumference of a circle, and today we're going to do area of a circle and area of that sector. So from previous classes, we know that area of a circle is pi r squared, and we're units squared when we're done. Now, this, unlike circumference, we could use diameter or radius, but here we can only use the radius. So we need to remember that. So area equals pi r squared. Our first example, our radius is 5. Didn't copy very well. And so I have area equals 5 squared pi. So 25 pi units squared. Now this is the exact answer, and sometimes you'll need that exact answer, and other times they will ask for you approximately. Remember, we're using nearest tenth, and make sure you use your approximate symbol with little curvies. And so when I plug that in my calculator, I get 78.5 units squared. So here's one for you to try on your own, so pause. So diameter is 16, so my radius is 16 divided by 2, which is 8. So area equals pi times 8 squared. So area is 64 pi units squared, or approximately 201.1 units squared. So when we did the length of a sector, that portion of the circumference, we took the circumference equation and then just multiplied it by the ratio of that angle. So we're going to do the same thing. So the area of a sector is going to be the area of a circle. So we have pi r squared times that ratio of the angle I'm given, the theta, over 360, because that's the whole circle. So that is pi r squared theta divided by 360. So we can put that all in your calc all at one time. So here we have 60 and 8. So the area of the sector is going to be pi times the radius squared, so 8 squared, 64, times the theta, which is 60, all over 360 degrees on both of them, sorry. And 60 goes into 360, so the 0 and the 0, and it all goes in there 6. And I still have 64 and 6 in the denominator. So 6 doesn't go into 64, but 2 goes into both of them. So this could be 32, and this could be 3. So the area, the exact answer would be 32 times pi divided by 3. And we don't have units on this one again, so units squared. Or approximately, when I put this in my calculator, I don't know, I didn't put this one in my calculator evidently on my notes. So I guess I'll just show you how I put it in. So I have 32 pi divided by 3. And you get that approximately 33.5 units squared. Now, just a side note, if I want to take 25 times pi, I can't just put 25 pi in there because they're going to give me an answer of 25 pi. Sorry, I got reflection on there. So I need to put 25 point pi, and it will then give me a decimal answer. So just remember to put that decimal if you're not doing a fraction. Okay, so our next page of notes says find the area of the big and small sector. So if we look at this, I have a small sector right here, but then I also have this big sector right here. There can be 2. There can be more than one in a circle because a sector definition is just a portion of a circle. So in order to label these better, we need to have some labels on our circle, and I can have A and B, and I need to have one more, so let's put it F, just for fun. So we'll do the small one first. So small, I'm going to label it small, but how we would do it is we'd say the area of, and we do AB and put that arc over there so that shows sector, so the area of the sector AB. So again, it is not 2, I was going to do sector length. The area is pi r squared theta divided by 360, that portion of the actual area formula. So we have pi times r, which is 6, squared is 36, times theta, which is 45, over 360 degrees. So 45 does go into 360 8 times. So that comes in 8. And let's see, 36 and 8 have a 4 in both. So this is 9, and this is 2. So my exact answer is 9 pi over 2 units squared. So when I put that in my calculator, I get approximately 14.1 units squared. So now the large sector, or the big sector, I guess they call it here. We'll use the words they use. So we have the big. And when we do this type of thing, you need to have 3 points, and I named it F. You can't see it through my work. I should have put that in a better spot, I guess. We label it as the area of, again, the parenthesis says of, and you start at the beginning point, you put a middle point, and you put the ending point. So that would be the arc sustained by AFB. And if there was more points in here, it doesn't matter. You just choose the beginning, the end, and something in between. So we go across there. We got pi. R is still 6, so we have 36. But we need theta. Well, if this is 45, this whole rest of it is going to be a whole circle, 360 minus 45, and gives me 315. So I have 315 divided by 360. So again, I forgot my degrees. So my degrees reduce out. 36 goes into 360 10 times. And let's say 5 goes into both, so that's 5 here. And 5 goes into 36. Carry 1 is 3, so I have 63. So I have 63 pi over 5 units squared, which is approximately 99.0 units squared. Or 0.0, excuse me. So we just take them individually. So we got one more just to try real quick. So this 80 is kind of different. That 80 should be right in here. So if that's 80, the rest of it would be 360 minus 80. There's 360 minus 80, which would be 260. So this whole other angle is 260. And we need another point over here, so how about K? It can be any variable. So the area of the smaller one, which would be CD, and then the sector, is pi r squared, r is 4, so 16, times my angle, which is 80, over 360. And I forgot my degree symbols again. I do that good. So I can reduce these zeros in the degree. I don't know, I'm going to do 16 and 36. 4 goes into both of those. So 4 goes into 16 4 times. And 4 goes into 36 9 times. So I'm left with 4 times 8 in the numerator, which is 32 pi over 9. And we got feet on this one, so that would be feet squared, or approximately, when I put it in my calculator, 39.1 feet square feet. So then I need the area of the larger one, so beginning, end, and a point in the middle. So C, K, D in an arc to show it's a sector, not an angle. And so then we again have pi. Our radius is still 4, so 4 squared is 16, but our angle this time is 260, subtracting the 80 from 360. All over 360. Okay, so our zeros and degrees can reduce. How about I subtract correctly? This would be 280. I did that in class as well. My brain evidently doesn't want to subtract correctly today. Okay, so this is 28. So I like to see, I get this, 4 goes into both of these, so 7 and 9. So I need to take 7 times 16, so 7 times 2 is 42, so 2 carry a 4, 7 plus 4 is 11, so I have 112 pi over 9, which is going to be approximately, how about I put the right answer, 39.1 feet squared. Now this is the bad thing about not doing it with you, and you should be yelling at me at home because I wrote down the wrong approximation up here too. This would be 11.2 for the smaller one. I apologize. So if you did it with me at home, you're right with 11.2. Your notes are missing something on the next one. It says find the radius if the area equals 254.5, and that's the area of the whole circle. Okay, so the area of a whole circle is 2 pi, not 2 pi. I keep wanting to do circumference today. It's pi r squared. So I just need to find this r, don't I? So area equals 254.5 equals pi r squared. So this is multiplication, so I can divide by pi on both sides. So these reduce. Now I have this r squared, and thinking back to the Pythagorean theorem when I had a squared or b squared or c squared, I have to undo that square, so I have to take the square root of both sides, but it's the square root of the whole thing over here. So our exact answer equals the square root of 254.5 divided by pi. And I don't know that in my head, so I'm going to throw that into a calculator. And we get approximately 9.0 units. And it's not squared because we're just looking for the radius. Okay, our last page, 3 examples here left. So we have find the area of T. Well, T is the whole circle, and I only have some information about the sector. I know the area of the sector is 6.28. Well, to find the area of T, well, the area of T is going to be pi r squared, right? So we need to use this information to help us out. Well, the area of here is area equal pi r squared theta over 360. Okay, so we're going to plug some things in. So I have area is 6.28 equals pi r squared times theta, which is 45. 45 degrees over 360 degrees. Well, 45 goes into 360, well, 8 times. We did that before already. So I just noticed something. Look at this right here. Isn't that the area of T? Because we have right here. It is. So we don't need to solve this for r and plug it back in and everything. We can just solve it for pi r squared. Well, I have 1/8. So to do that to the other side, I have to multiply by 8 over 1, the reciprocal. So multiply by 8 over here. So the area of T is pi r squared. Well, we just found pi r squared to be 8 times 6.28. Okay, so let's see. 8 times 6.28. I get 50.2, approximately 50.2 units squared. So that was kind of neat. We didn't have to make it too hard, did we? So watch out for those little shortcuts. Okay, so we've done, the next two are find areas, shaded regions, so we're going to have to take and subtract. So we have a big circle here, and then we have two little circles, and I know this is 3, so this part's 3, and I know this is 2, so this part is 2. So what I'm going to have to do is take the area of the large circle and subtract these two other areas. So we got the area of, well, the large circle is pi. Well, now we need r squared. Well, if the whole thing across is 6 plus 6 plus 2 plus 2, so the diameter is 10, the radius would be 5. So 5 squared, okay. And then we're going to subtract, and we have this circle here. Well, the radius is 3, it tells me right here. So that would be pi times 3 squared. And then this circle, well, the radius is 2, so it'd be pi 2 squared. Well, we get 25 pi minus 9 pi minus 4 pi. Well, since they all have pi's, that means they're like terms. So all I have to do is really take 25 minus 9 minus 4. Well, they're both negatives, so 25 pi minus 13 pi. Well, that would be 12 pi. So my area is 12 pi units squared, which is approximately 37.7 units squared. So we're just doing our subtraction again. Okay, so now we have find the area of the shaded region again, and we're going to shade here on your paper. It looks like there's little, well, PowerPoint, I'm sorry, that was shaded there. So we're going to have the circle, we're going to have the area equals the circle area minus the rectangle area. So just a little diagram to see what we're going to do. Well, in order to find the area of the circle, I need the radius, but I have a right triangle here that would allow me to find the diameter and divide by 2, because that is a right triangle. So I need to use the Pythagorean theorem. So I would have 25 plus 144, and I would take the square root. I'll define the c, so square root of 169, which is 13 from our squares and cubes. So this is 13, which is also my diameter. So my radius would be 13 divided by 2, which is also 6.5. Now I'm going to show you what both 6.5 and 13 has. Okay, so I have area equals pi r squared, so 13 over 2 squared, minus the area here. Well, it's a rectangle, so it's base times height, so 5 times 12. It's about ready to say the answer. So then 13 squared is 169, 2 squared is 4 pi, minus 60. Well, I don't know that, so I'm going to put it in my calculator all at one time. I'm just going to put 169 pi divided by 4 minus 60, because it's going to follow order of operations, and I'm going to get approximately 72.7 centimeters squared. Okay, now I said I'd do it with the 6.5 also. So we have area equals pi times 6.5 squared minus 60, because we already figured that out, and I don't know 6.5 squared, so I'm going to just put in my calculator pi times, doing parentheses, 6.5, square it, minus 60. And I get the same answer. So 72.7. So either way you do it, I wanted to show you that it does work. The only plus to doing the fraction is I know 13 squared and I know 2 squared, but I don't know 6.5 squared, which would be the same as 65 squared. So that's our video for today, and you'll have the worksheet I'll hand out in class, or it is also on the calendar.